Okay, now we're going to talk about the steps of graphing a rational function. So first thing we're going to do is determine if the graph has symmetry. And we know what symmetry is. We've talked about that enough already, okay? We're going to plug in a negative x into our f of x and see if we get back the same function. If we do, we know that that is an even function and it's going to have symmetry with respect to the y-axis. Now, if we get back the opposite of our original function, then we know that that's odd and it's going to have symmetry with respect to the origin. Okay, that's our first step. Second step, we're going to find the x-intercept, and we do that by setting p of x equal to 0. Okay. Also, you can think about that as y, but we're just going to simply set the top part, the p of x, equal to 0. Okay. Then we're going to find the y-intercept by setting x equal to 0. That's our third step. Fourth step, we're going to find any vertical asymptote by solving q of x equals 0. Now this is the denominator. We find the vertical asymptote by setting the denominator equal to 0 and solving, okay? Fifth step, find the horizontal asymptote. We do this by using our rules. I'm going to write them very small over here on the side. So if n is less than m, y equals 0. If n equals m, then we use our coefficients. And if n is greater than m, there is no HA. Okay? That right there is a little semicolon, in case you were wondering. Okay, now we're going to plot at least one point from between and beyond the x-intercepts and the vertical asymptotes. And this is because that is where your graph will change directions, okay? The x-intercepts and the vertical asymptotes is where your graph can change directions. That's why we do points between and beyond. And then now we're going to use the information to graph the function between and beyond the vertical asymptotes. So those are the 7 steps. I guess I need to tell you guys that this exam is going to be the exam that has the most steps on it. So, but don't worry, you get your little fact sheet that will have all the steps on it. So that makes it a little bit easier. Okay, let's do some of these. So first thing that we're going to find is symmetry. We're going to plug in negative x for all of our x's. So f of negative x is going to equal 2 times negative x minus 1 all over negative x minus 1. So 2 times negative x gives us negative 2, x minus 1 over negative x minus 1. So this one changed, this one did not, right? This one changed, this one did not. So some changed, but not all changed. So that means that it's symmetric with respect to, that's what this means, with respect to neither. Now, we are going to find our x-intercepts. That's our second step. We're going to do that by setting p of x. This p of x. This is our q of x. Remember that. It's kind of helpful. So we're going to set p of x equal to 0. We also need to remember that p of x equals y. That's helpful. So we're going to say 0, 2x minus 1. And then now we just solve for x. So I'm pretty sure you guys can do that. Add 1 to both sides. That's going to give us 1 equals 2x. Now we divide by 2. So then these cancel. So we get x equals 1/2. But this is an intercept, so we have to write it as an ordered pair. So it's 1/2, comma 0. And we know that our y is 0 because we set it equal to 0 here. So we can put that on here. That's our x-intercept, so we know at 1/2 our y is 0. Now let's find our x-intercept. No, wrong, y-intercept, sorry, said it wrong. When we find our y-intercept, we always set the opposite variable equal to 0. So we're going to have f of 0 equals 2 times 0 minus 1 over 0 minus 1. So that's going to give us 0 minus 1, well, over negative 1, which is negative 1 over negative 1, which equals 1, right? But we also, since this is an intercept, we need to write that as an ordered pair. Our x is 0 and our y is 1. So if we graph that, x is 0, y is 1 would be here. Okay. Next step, we're going to find our vertical asymptote. So 4. Find our VA. So we do that by setting our q of x, our denominator. So we'll say 0, or let's do x minus 1 equals 0. That's the way I like the 0 on the right-hand side. So if we add 1 to both sides, x equals 1. Remember, this is denoted by a dashed line. So we're going to have a vertical asymptote here. Next, let's find our horizontal asymptote. We use our rules. So we're going to look, it's kind of crooked bit because I've been my page, but we're going to look at our n is what? Well, it's 1. And our m equals 1. So our n equals our m. So that implies that we're going to use our coefficients. So our coefficient on top is 2. On bottom is 1. So 2. So our HA is at y equals 2. So we'll go up here and we're going to, at 2, we're going to do our dotted line. Because that's where AJ is. Excuse me. Next, we have to find test points between and beyond our x-intercept and our VA. So that's going to be our number 6. I'm going to do that over here. BTW in between. So we're going to look for our x-intercept was where? Well, it was 1/2. So we're going to go 1/2. So we're going to go beyond 1/2. So like our 1/2 was here. We're going to look for 1 here. Then we have to find one between 1/2 and 1. So there's one little section right here that we're going to have to do. And we're going to have to go from our VA, which our VA was 1. So we're going to have to do one from 1 on out. Okay. So when we pick one over here, let's do an XY table. That's how I did it. Last time it's so much easier that way. So to pick past our x-intercept and our VA, so we want to pick one past 1/2. So we could go over here and let's just pick, I picked -2. Now to pick between 1/2 and 1, I picked 3/4. Because that's really, there's not much to pick in between there. You can't pick a whole number, so that kind of sucks. And then to pick one number past 1, I just picked 2. Now what we do is we plug these into our function and see what we get out of it. So we're going to take f of negative 2, that's going to equal 2 times negative 2 minus 1 over negative 2 minus 1. So 2 times a negative 2 is a negative 4. That's going to give us negative 5 over negative 3, which gives us approximately 1.666 continuously. So our output here is 1.67. We could round that. Plug in f of 3/4. That equals 2 times 3/4 minus 1 over 3/4 minus 1. So 0.5 over negative 0.25. Let's correct my mistake there. That's going to give us a negative 2. So negative 2 is going to be our output here. Just speed up a little bit more. Plug 2 in, that's going to be f of 2. So 2 times 2 minus 1 over 2 minus 1. So this is 4 minus 1 gives us 3 over 1, which gives us 3. So 3 is going to be our output. We could write these like ordered pairs. So this could be negative 2, comma 1.67, 3/4, negative 2, and 2, comma 3. Now we can put those on the graph and see how it's going to graph for us. So at negative 2, we're going to get 1.67. So at negative 2, 1.67, it's going to be somewhere right in here. Terrible dot, sorry. Didn't mean for it to run off. At 3/4, here, it's going to be negative 2. So it's going to be somewhere down here. And then at 2, it's going to be positive 3. So x is at 2, it's going to be positive 3. 1, 2, 3. So it's going to be up here. So we can see, I'll take a different color, and we can see that this one, as it makes its bend this way, is getting infinitesimally closer. That's the math word, Shelley word, super duper. Here it's getting infinitesimally closer, but it will not touch either of these on this graph. We know it cannot touch the vertical one ever. It can't cross the horizontal, but it does not this time. And this one is going to be, comes infinitesimally close here, and it's going to make a turn, touch that point, and then it's going to turn this way. If you wanted to take more points, you could, so that you can see exactly where it touches over here on, like, say, 8, or over that way. But that was enough points for you to see that this is going to turn and go that way, and that one turns and goes that way, okay? That's how you graph the rational. All right, let's do another one. Once again, we're going to try to find symmetry. We're not going to try, we are going to do it, actually. So we plug in our negative x. We take f of negative x. This is going to be 3 times negative x squared over negative x squared, minus 4. Now, since this is an even exponent, that's going to eat your negative, because negative times a negative is always a positive, right? So this is going to be 3 times x squared. Same thing's going to happen down here because this is an even exponent. So this is going to be x squared minus 4. So we plugged in a negative x, and we got back the exact same function. So that's an even function, which means that it has symmetry with respect to what? The y-axis. I know you all know that. Okay, right on. We know that whatever it looks like on this side of the y-axis, it's going to look like on this side of the y-axis. Whatever it looks like on this side of the y, like if it's a parabola, it's going to look the exact same, right? That's what symmetry with the y-axis means. We can fold it in half, it looks the same. Right on. Okay, now let's find our x-intercept. Find that, remember what we said equal to 0? The p of x, just the top. P of x equals y. So we're going to take 3x squared equals 0. So for that, we're going to divide both sides by 3, right? Because we want the x by himself. So x squared equals 0. Well, that implies that x equals 0. Because if you took the square root of both sides, yada yada, y'all know all that. Okay, so our x equals 0. What does our y equal? Well, it equals 0. So our x-intercept is the origin. 0, 0 is called the origin. Okay, now let's find the y-intercept. Y-intercept, we always set the opposite variable equal to 0. We're going to say f of 0 equals 3 times, well, 0 squared, we know what that is. And this is going to be 0 squared minus 4. So that's going to be 0 over 4, which equals 0. So our y-intercept, 0, 0. Let me tell you guys a little hint, a little trick, something that's always true. There's not a lot of times I can say always in math, so I love it when I can. If your x-intercept is 0, 0, your y-intercept is going to be 0, 0, without fail. Because if it crosses here on the x-axis, it's going to cross here on the y-axis, okay? So we share the same point. I'm just going to put a little light blue ring around it, okay? But that's always true. If your x-intercept is 0, 0, your y-intercept is going to be 0, 0. Just know that. It'll save you some time on the test. Okay, now let's find our VA, number 4. VA, vertical asymptote. Sorry, I use slang. So to find your VA, we set our Q of x equal to 0, and that's because our Q of x is our denominator, right? So we're going to set x squared minus 4 equal to 0. Move our 4 over, so that's going to equal 4. To solve for that, that's right, square root. Can never forget your plus minus though. So that means that our x equals plus minus 2. So VA is at x equals negative 2 and 2. Write it as 2. That way it's easier to see that you're going to have 2 VAs, right? You don't want to blow that. Okay. So we have a negative 2. Just write 1. Your graph's going to be all jacked up. Positive 2. Let's find our AHA. It should be the easiest one because you really don't have to do much math, right? We just use the rules on this one. Rules aren't hard. So, rule. First thing we got to do is look at our N. What is our N? It's 2. What is our M? Again, it's 2. So our N equals our M. When our N equals our M, that means that we're going to use our coefficients, okay? So that our Y is going to equal 3 over 1, which equals 3. Cool? So our HA is at Y equals 3. Okay? So we're just going to go up here 1, 2, 3, make our dashed line across. There we go. Okay. So now all we have to do is our test points and we'll be finished. So I'm going to do those up here so we can see them better. So remember they're between, beyond, intercepts, and what? VAs. So our VA is here and here. So we know we have to pick them there, right? And our x-intercept was 0, 0. So we have to pick between here and here, here and here. That's not real hard. So if our VA is -2, I usually just go one past, so I'm going to pick -3. This was 2, so I'm going to pick 3. Especially with squares, because that's going to give me like this same exact output, and that is so much easier. So if this is 0, I'm going to go -1, and then +1. Those are the ones I'm going to pick, okay? So let's do my XY table. So I picked a -3, a -1, and a 3. Okay, those are the ones I picked. So we're going to take these numbers once again and just plug them into our original function. I didn't leave myself much room to, well, I could do it down here, I guess. So our original function, so I'm going to take these, I'm going to say f of -3 equals 3 times -3 squared over -3 squared minus 4. That's 3 times 9, that's going to give me 27. 9 minus 4 over 5. Divide that into each other, that's going to give us like approximately 5.4. Now let's do -1. F of -1, 3 times -1 squared, -1 squared minus 4. 3 times 1 is going to give us 3. 1 minus 4 is going to give us a -3. That's going to be a -1, right? 1, -1. We plug 1 in, it's going to give us the same number. So we're going to get 1, -1. And we plug 3 in, it's going to give us the same number. So it's going to be 5.4. That's the cool thing about squares. Because 3 squared gives you the same output, okay? So now we could just say -3, 5.4. -1, -1, 1, -1, and 3, 5.4. And then now we could just graph these, okay? So let's go over here to -3. Here's -3. We're going to go 5.4. So 1, 2, 3, 1, 2, 3, 4, 5. 5.4 is about 5.5 right there. Now, let's go -1, -1. It's going to be here. Okay? Now we're going to go +1, -1, and it's going to be here. So they're both right there. And if we go +3, 5.4, 3, 1, 2, 3, 4, 5, and we know that they're all going to be mirror of themselves on the y-axis because it's got symmetry to the y-axis. So this crosses here, so it's going to have to go downward, and it's going to get infinitesimally close here. I should have used a different colored pen. I'm so sorry. But never cross or touch. I'm so sorry. I was super close there, wasn't I? Now, since this one's here, we're going to come super duper close here and make our turn, and then go back out this way. Well, that was not a good line. Sorry. And then we're going to come in infinitesimally close here, make our turn, and then shoot back out this way. Okay, there you go. And that would have been my step 7. You know, there's that 7th step that I hardly ever write down because that's just graphing it. So 7, graph. And that's how you do it. A lot of steps, right? Like I'm telling you, a lot of steps on this test. Lot. Okay. And another. Practice makes perfect. That's why we're just doing it over and over and over again. I know you're thinking, my God, Shelley, why so many? Because it's a lot of steps, that's why. So number 1, symmetry. Put SYM because well, I've told you 1,000 times, I'm lazy. So 2 times -x squared over -x squared minus 9. So if it's an even power, what does that do to the negative? It does eat it. You're right. So that's going to be 2 times x squared. Now this one's going to eat that negative, so that's going to spit back out the same thing, right? X squared minus 9. So since we plugged in a negative x and it spit out the same function, right? What does that make the symmetry? It's symmetric with respect to, it's an even function, so that would be the y-axis. Remember that? Please put it in your calculator and look at it. It will tell you, okay? Right on. It will even show you how to graph it. Like, yeah, okay. Like if you're completely twisted up, put it in your calculator. That'll give you a hint, yeah? All right. So now, let's find our x-intercept, number 2. But you can't just put it in your calculator and graph it because, oh, I'm sorry. Yes, you can. You're not in my in-person class. Yes, you can. There you go. Yes, you can. P of x equals 0. Yes, you can. Okay. So now we're going to find this. We're going to take 2x squared equals 0, just like before. We divide by the coefficient. X squared equals 0. If you were to take the square root of both sides, that's going to tell you that x equals 0, right? Okay. Write that as an order pair for me, please. 0, 0. Right on. Now, what did I say? What's my little trick here? Sorry. Right on. If you're, let me write down this. Can't write and think at the same time. It's too hard. So if your x-intercept is 0, 0, your y-intercept is going to be 0, so 0. So I don't care if you do this. Whatever. That's it. You know it. Just know it. Just know it. Beautiful. You know it. Number 4. Find your VA. So we're going to take, for VA, we take our Q of x. So x squared minus 9 equals 0. Sorry, here goes my voice. So x squared equals 9, square root, don't forget your plus minus. So x equals plus minus 3, all right? So your VA is at x equals negative 3 and 3. So 1, 2, 3. Make sure when it's a VA that you put it vertically, not horizontally. Here we go. Now let's find our HA. This is where we use our rules, right? So what's my power? N equals 2, M equals 2. This implies coefficient. So y equals 2 over 1 or 2. So my HA is at y equals 2. So go up here to 2. This one's horizontal. Beautiful. Now, test points. We're going to have one here and here, right? Past the VAs. And then in between the VA and the x-intercept. So our VA is at negative 3. Let's pick negative 4. Positive 4. Our x-intercept is 0, so let's pick negative 1 and 1. Cool? And that's how I pick mine. So now let's just plug them in. FF of negative 4, 2 times negative 4 squared over negative 4 squared minus 9. That equals 32 over 7. Oh, that's an approximation, sorry, of 4.5 0.57. F of negative 1, which is 2 times negative 1 squared over negative 1 squared minus 9. So it's going to be 2 over negative 8, which is another approximation, Shelley. Negative 0.25. It's going to be negative 0.25 because it gives you the same output, right? And 4.57. Repairs. And we can just plot those. Do it in a different color this time. Yeah. Okay, so negative 4, and it's going to be 4.57. 1, 2, 3, 4. So on positive 4, it's going to be the same one because we have symmetry about the y-axis, right? So negative 1, it's going to be down here. This one is 2, positive 1. So now we just graph it. Do that. So this was number 6. So number 7, we're going to graph. Kind of going backward, but this will just go this way. Infinitesimal. You can do it either way, whichever one you want to go first. Now, I'm going to make another video for this. This one's way long. Okay, I'll come back and do slants.